Here we come to DSE Physics 2017 structure question 5. So here we have a turntable with a teapot on it, and when it rotates, part A, we have to draw and label all the forces acting on this teapot. First of all, the teapot is attracted by the earth with the gravitational force. We have mg, and also we have a supporting force that prevents the teapot from going down. So we have the reaction, normal reaction. So when the teapot is rotating, there should be a centripetal force that points towards the center. And here, the centripetal force is provided by the friction. So because of friction, the teapot will be fixed to the turntable and rotate together with the turntable. And this frictional force is pointing towards the center, centripetal force. Part B, taking the teapot as a point mass, we need to estimate the net force, F, acting on the teapot when the turntable is rotating at a rate of 0.5 revolutions per second. So what is this? 0.5 revolutions per second. That means the turntable is rotating for 0.5 revolution per second. This is talking about the angular speed. Of course, we have to change the units because normally we would use radian per second. So bear in mind that 1 revolution is 2 pi. So now we have this much of radian per second, which is equals to 1 pi radian per second. So omega is known. So if omega is known, now we would like to find the force. So force can be given by mv squared over r, or force can be given by mr omega squared. So you have to decide which equation are we using now. We are using this. We are not using this. But why? Because if you see carefully, the linear speed is not given. Okay? We only know the angular speed, which is already found here. So we would not use this. So let's put in the numbers on the right hand side. Mass of teapot is 1. Radius is 30 cm. That means 0.3 meter. Omega is pi. So we have the force on the teapot is 2.96. Because we are talking about force, the unit will be Newton. Okay, part C. Part C is saying that the turntable is suddenly stopped and the teapot slips. Now let us take a step back. What is happening? I will show you using a top wheel of the turntable. So the turntable is turning. This is the top wheel. It will continue turning with a angular speed of pi radian. So at the same time, the teapot, because it's fixed to the turntable, it would also turn in this direction. But if we look at this moment, when the teapot is at here, the linear speed of the teapot would be along this direction. So we can find the linear speed of the teapot with a known angular speed, and V would be equals to r omega. The radius is 0.3, omega is pi radian per second. So we have 0.942. This is talking about linear speed, so the unit is meter per second. Okay, so now what? We already know the teapot is moving when the turntable is rotating. If you keep rotating at a constant speed, the teapot will move with a constant speed. It will not stop. However, this is not the case. In this case, we are taking our hand, stop the turntable. And when the turntable is stopped, due to inertia, the teapot will continue to move forward. I will illustrate using a side wheel. So we have a turntable surface like this. The teapot is originally moving. I would use U to indicate the initial speed. U is equals to 0.492, but it suddenly stopped. The ground suddenly stopped. The turntable suddenly stopped. So the teapot will continue to move on because of inertia. However, because there is a friction, it is said that friction is equals to 10 Newton. Okay, so the teapot will decelerate, and sooner or later it will come to a stop, which means the V will be 0. And we are going to find what? We are going to find the distance d before it comes to stop. So first of all, in this decelerating motion, I would like to find the acceleration first. So by F equals ma, we know that the force acting on the teapot is 10 Newton. Mass of the teapot is 1. So the acceleration is equals to 10 meter per second square. Once we know the acceleration, we can make use of the equations of motion. V square equals U square plus 2as. So V square is the final speed, which is 0. U square is 0.942 plus 2a. Because it's decelerating, I will add a negative sign to the acceleration. And the displacement here is d. Solving this equation, we would have d equals to 0.0444 meter. So this is the distance that's the teapot will slip through